NWCG Fire Danger Subcommittee presented this PowerPoint before the NWCG Executive Board on September 17, 2014. The NWCG Executive Board approved the subcommittee request to begin implementation of 3 updates to the NFDRS. Incorporate the growing season index to compute live fuel moistures. Incorporate the Nielsen model to compute fine dead fuel moisture. And reduce the number of fuel models in the NFDRS. This PowerPoint highlights the rationale for the changes to the NFDRS. The associated NWCG memo, NWCG Memorandum Number 14-018, and briefing paper can be found on the NWCG website at www.nwcg.gov/general/memos.
Today I'd like to talk to you about proposed updates to the National Fire Danger Rating System. Before we get started, I wanted to introduce the National Fire Danger Rating System Subcommittee. My name is John Wallace. I'm with the U.S. Fish and Wildlife Service. I'm the chair of the group. Russ Grip, the co-chair of the group, is with the U.S. Forest Service. Linnea Keating, also with the U.S. Forest Service, is the National RAWS Coordinator. Lonnie Williams is an information technology specialist who manages the Weather Information Management System program, or WIMS. Larry Bradshaw is a research meteorologist at the Missoula Fire Lab for the U.S. Forest Service. Matt Jolly is a research ecologist specializing in fire danger and fire behavior applications at the Missoula Fire Lab with the U.S. Forest Service. Kai Olson is a center manager for the southern area, representing the GAC center managers. Don Koppel is a representative of the National Association of State Foresters in the western states. He's from the state of Montana. Brad Smith, the National Association of State Foresters from the eastern states, works for the state of Texas. Clint Cross is the U.S. Forest Service representative on the group, as well as the Advanced NFDRS Training Chair. Steve Larrabee and Pat Phillips are with the Bureau of Indian Affairs. Carla Luttrell is with the Bureau of Land Management. Dan Mendar is with the National Park Service and also represents the WFDS group. Heath Hockenberry is with the National Weather Service. And so that's our group. One of the things that I wanted to point out before we get started is while the underpinnings of the system, NFDRS system, are going to change significantly, it's important to emphasize that the outputs from the system will be the same. You're still going to see energy release components, burning indexes, spread components, ignition components, Keach Byram drought index, fuel moisture values, all those outputs that you're used to seeing, you're still going to see them. None of them are going to change. And so that's going to help to ensure a smooth transition from the old system to the new updated system. And so what we're proposing, and another thing to remember up front, is this system has remained static and unchanged for almost 40 years. Not much we do today remains unchanged for that long. And so we're looking at updating 3 components to the system: the live fuel moisture model, the dead fuel moisture model, and then we're also wanting to consolidate existing fuel models to 4 fuel response types based on existing fire behavior fuel models. And so the cases for change, as you all know, NFDRS is a very complex program right now, and much of that complexity adds little insight. A lot of the complexity in the program is in there simply to tweak problems with the model. It's been recognized all along that the live fuel moisture model inside of NFDRS is problematic. And so there were tweaks that were developed to overcome these problems with that model. And so all those tweaks and cheats and additions that we've had to make over the years to try to make the system work better they just add complexity, and they make it a lot harder to understand. At the same time, fire danger expertise is diminishing. We're losing a lot of the folks that helped develop the 78 and 88 systems to retirements, and so we're wanting to simplify it. If we make it simpler, it'll be easier to teach the next generation of folks how to use a system and give them a system that works well. Practitioners demand it. We're going to simplify WIMS operations. Right now, every day we have to go in and edit our observations in WIMS, look at states of the weather, look at season codes and greenness factors and wet flags and things like that. And a lot of that's going to go away with this update. Those were all tweaks that were designed to overcome the imperfections in the live and dead fuel moisture models. And so when we clean those models up, those tweaks will go away and make things a lot more simple. The updated system is going to provide clearer and more intuitive outputs. And that, a lot of it is related to moving to the 4 fuel model groups. And I'll talk about that in a few minutes. And it's an extension of logic that's been taught for years. You know, we've been talking about simplifying the system, and we've been in the 491 class, the intermediate NFDRS class. We talk about the tweaks, and they just don't make sense. And so we're hoping that this is really going to clean things up and make it much easier. Another, and perhaps the biggest case for change, is almost every fatality investigation that's been done in the last 30 years has pointed to a lack of knowledge of local fire danger as a contributing factor. And a lot of that lack of knowledge is because the system's so complex and hard to understand. And so we're wanting to make it easier. Another case for change, and one of the big reasons for the 4 fuel model groups, is that this is going to prepare us to integrate new technology into NFDRS, specifically gridded weather analysis, so that in the future, not with this update, but in the near future, NFDRS will become more spatially oriented. And we've been preparing to do this for a long time. Since I started installing remote automated weather stations in the southeast at the inception of the National Fire Plan, we were putting solar radiation sensors on those raw stations in 2000, 2001 with the idea that the new Nelson fuel moisture model would be able to be run on those stations. And so that was 13, 14 years ago. And we're just now getting to the point that we're ready to actually start running that model on those stations that have been equipped to run them for that long. The last several years we've been really looking at the new model performance. We've been looking at the dead fuel moisture model, the new live fuel moisture models, and evaluating their performance to make sure they work the way we think they're going to work before we implement them in the program. And so that brings us to the new live fuel moisture model. The growing season index, you're also going to hear this referred to as the live fuel index, or LFI. The current live fuel moisture model, the one that we've got in NFDRS now, is acknowledged as the weakest model in NFDRS. And so in 1972, when they first developed the system, the developers told us that the live fuel moisture model needed to be replaced as soon as possible, that what they had developed in the early 70s was only a placeholder. And so we've been using that placeholder for 40 years. This new GSI live fuel moisture model is a meteorological-based phenology model. And so what it does is it takes weather observations from our RAW stations and converts them into a live fuel moisture based on the once daily fire weather observations. It requires no constant human intervention. Before we've had to put in green updates and freeze dates, and those were not easy to come up with a lot of times. And so this new model isn't going to require any of that. It's going to run 365 days a year. And it's currently running in the WIMS test system. So all of this is these two live and dead fuel moisture models. They're already in the system. They're already running. We've been testing them for quite a while, and they're working really well. And so this is kind of what the GSI looks like. And we put this graph up. It's from Nevada, sagebrush moisture graph. And so it compares the live fuel index, or the growing season index, on the red line to the actual measured live fuel moisture in sagebrush. And so you can see the red line isn't perfect with the measured live fuel moisture, but for model data it's pretty darn good. And this works well in every system that we've looked at around the country. And we've correlated it back to satellite-derived greenness imagery, and it works really well. We haven't found a place in the country where it doesn't work to this level of precision yet. And so next let's talk a little about the fine dead fuel moisture model, the dead fuel moisture model. The model we're currently using was developed by Fosberg in the 1970s, and it was based on the old 1955 California Fire Danger Index. And so it's pretty old technology. It uses once daily weather information, that's 1300 OB, and it requires state of the weather and fuels wet codes to be entered. Again, those tweaks that make the system more complex. In this, the model that we're using now, the current model, the Fosberg model, is calibrated only for mid-afternoon conditions. The new model, the Nelson dead fuel moisture model, more accurately models diurnal fine dead fuel moisture using elements from hourly fire weather observations. And so it's going to give you a lot better picture of what the dead fuel moisture is on an hour-by-hour basis based on the observations that have come off that weather station over the past 24 hours. We all know that dead fuel moisture isn't going to be reflected well if you just take a snapshot and look at a 1 hour period. It's all the weather that leads up to that snapshot that contributes to what the fine dead fuel moisture actually is. And so Nelson model, the new model, captures that lead-in period to that snapshot much better. Again, this model requires no daily human intervention. There are no tweaks involved with it. And again, it's been running in the WIMS test system since 2011. While not part of the Nelson model, in the same update, the automated state of the weather was implemented based on solar radiation at 1300 observation time and measured precipitation over the past 24 hours. And so, that was another one of the tweaks that we've had to do in the past, was that state of the weather. The dispatcher, whoever was entering the daily observation, had to stick their head out of the window and look and decide what the cloud cover was. And so, as part of the update that came along with the Nelson model being put into WIMS, that automated state of the weather was put in as well. And so this is what the Nelson dead fuel moisture model looks like as compared to the Fosberg, or the current model. The Nelson is in red, the Fosberg is in the blue dashed lines. One of the reasons for the 1988 update to the National Fire Danger Rating System is that fire managers told the NFDRS group that fire danger was too high after a rain event. The Fosberg, as you can see on this graph, when there was rain, the Fosberg fuel moistures didn't reflect it as well. And so now, when you're looking at 24-hour values, the Nelson dead fuel moisture model captures those rain events much better and show that, in fact, fuel moisture increases after a rain, and as fuel moisture increases, fire danger decreases. And it stays down for a longer period than the old Fosberg model allowed us to see. And And so the final update I want to talk about is the consolidation of fuel models. And so in 1972, when John Deeming's group first rolled out a national fire danger rating system, the system had 9 fuel models. And those were all based on Rothermel's spread models that they used for fire behavior. And so when Deeming was tasked with updating the National Fire Danger Rating System in 1978, he went before his steering committee and said, we only need 4 fuel models. We need to look at fuel model groups. Fire danger is a big scale planning picture. It looks at the grasslands south of Boise or the mountains with the timber north of Boise. That's the scale that fire danger was designed to look at. And so he said we only needed 4 fuel groups. But he had to negotiate with his steering committee, and in that negotiation they decided they would have 20 fuel models for the 78 system. And then when the 88 system was put into place, they added 20 more fuel models. And so we've got a total of 40 fire danger fuel models. And these aren't to be confused with the fire behavior fuel models. They're completely different. So the designers thought we needed 4. The steering committee thought we needed 20, and we ended up with 40. One of the neat things, though, that we've looked at in the last couple of years is the fact that Deeming and his group was correct. When you look at the outputs from most NFDRS fuel models, they aren't unique. So if you run one weather stream from one RAWS station through all of the fuel models, you get a picture kind of like what's up on the board now. And so on the y-axis, you've got the correlation. Now 1 is a perfect correlation. That means that the fuel models are identical. They're perfectly matched. The higher, the 0.75 correlation, means that they're poorly matched. And so you can see pretty quickly that several of these are matched pretty darn well. Fuel model A and L, grass models, very close. About a 0.96 correlation. Fuel models B, F, and T, which are mostly grass and brush, also have a very good correlation. The fuel models with minimal live component, excellent correlation. I, J, and K, which are currently slash models, are perfectly correlated. 1.0 correlation. That means that you're going to get the same exact answer no matter which one of those models you use. The scale is going to be a little different, but the answer is going to be the same. And that's that's a pretty important distinction. And then the models with more live fuels in them are also well correlated. And so when you look at these circles that are on the board, you see a W, an X, a Y, and a Z. Fuel model W, fuel model X, fuel model Y, and fuel model Z. And these are our new fuels groups that we're going to be using in the 2016 version of NFDRS. Again, you can see how well all of these fuel models that we currently use actually match. And so there's really no value gained in breaking out individual fuel models. It's not giving us a different story. All it's doing is adding complexity to the system. And so with that, we're going to talk about time frames a little bit. So in September of this year, NWCG approved us, the NFDRS Subcommittee, to proceed with changes to the system as outlined. In December of this year, we're going to be providing technical documentation for the new system in a draft form. And we'll be putting that up on the NWCG Fire Danger website, and that link will be provided. 2015 will be a big year for us. We'll be doing a lot of the development work, a lot of the outreach work. January, we'll be moving the new NFDRS system to the test side of WIMS. And that's just going to have a few people will be able to look at it, test it out, and try to break it. See if they can find problems with it, that sort of thing. It's important, again, to note that most of these changes are already in WIMS, but they just got to be tied together. And so it's going to be pretty simple to move that into the WIMS test side and start looking at it and doing the beta testing on it. By July of 2015, we're going to be developing webinars and self-paced training for prior S491 students to become familiar with the new system. A lot of that's going to be YouTube-based, much like the WIFTIS group does with their self-paced training. And so it'll be readily available for anyone that wants to check it out. We're also hoping that by July of 2015, we're going to release a new version of Fire Family Plus that's going to include the 2016 version of NFDRS. One of the other key components that I haven't talked about prior to this is getting fire danger into firefighters' hands earlier in their careers. Currently, fire danger isn't really talked about that much. We talk about pocket cards a little bit and refresher training, but that's it. And so by November of next year, we're going to be working with the fire behavior group here at NWCG to develop modules for the 90 series classes that teach firefighters of all experience levels more about fire danger, how to understand it and interpret it, how to use it. And there's going to be a lot more information coming out on pocket cards as well. There was recently a study done on pocket cards and their usefulness and their formatting, and we heard from the field that we needed to reformat the pocket cards, add some stuff, take away some stuff, and make them generally cleaner, easier to use and understand. And so we're going to be doing that by November of 2015 as well. And so by 2016, January 2016, we're going to move the new version of NFDRS over to the WIMS production side, so it'll be fully operational. And at that point, everyone will be able to get in, look at it, start using it, trying it out, testing it. But it's important to note that in January of 2016, the old versions of NFDRS aren't going away. The 78 and 88 versions that you're currently running will still be in WIMS and will stay in WIMS for at least 2 years, so that there's a time where we can look at things, compare things, and give the field time to transition over to the new system. And then by 2018, we're hoping that we'll be able to discontinue support of the 78 and 88 versions of NFDRS. That time, though, is not set in stone. It may go a little bit longer than that, depending on how the field is progressing with the training and with the transition. And so with that, that covers what I wanted to go over today. Thank you.